All right. So in the previous class, I explained R2 and adjusted R2. Okay. Very important phenomena. And as I told, it's what difficult to explain and understand in both the regards, you can say. See, R2 tells about variance explained. Okay. And if I say variance explained means, since you are having y equal to beta naught plus beta 1 x1 plus beta 2 x2 and so on, you are having x1 x2 as independent features. Okay, these are independent features. We are using these independent features for prediction, YP. That's what we are doing. Okay, so how much these independent features, how much, how much these independent features contribute to get the prediction. Okay, to get the prediction. That's what I called as R2. Yesterday also I told this thing. Today also I'm telling this thing. Because we assumed, understand, we assumed that the relationship between independent and dependent is linear. That is our assumption. Does how much this assumption holds? Okay, therefore R2 is a score which means the variance explained for y. Okay, for y, that means it tells what's the contribution of independent features in predicting y. It can come between 0 to 1. If it is 1, that means the independent features are highly contributing in prediction. In prediction, they are highly contributing. If the score is less, that means I don't have any contribution as such. Okay, they are not contributing much in the prediction of y. So that is R2. R2, okay. Now, we can, if we add, for example, let us suppose your R2 score is coming as 0.42. If we add more feature in the prediction, if the R2 score get increased to 0.60, that means that feature is also contributing in the prediction of y. But there is an issue. The issue is it may rise to overfitting. Okay, if you add more feature, doesn't matter that R2 is increasing. That means we are going to know, we are having a knowledge that okay, these features are contributing in the prediction of y. But if we add more features, though your R2 is increasing, but it may lead to overfitting. Okay. So R2 doesn't tell us about how many features. How many features. Having a good R2 score also doesn't mean that your model is good. Okay. Don't don't just rely only on R2. No, if you are getting high R2, that means high variance explained. That means independent features are having good contribution in the prediction of Y. But that's not only the factor to say that your model is best. No, we have other features also to talk about. We have other parameters also to talk about. Just as I told, MSC mean square error is our priority. Error is our priority to identify. Okay, we calculate R2 also, but there are issue with it. Like, it doesn't gives any information about how many features are there, who are contributing, what features are contributing. It is independent of beta naught and beta naught, beta 1. They are not contributing in R2. No, no contribution. Coefficients ka koi contribution is not in R2. You know what is the formula for R2? Just only I mentioned the formula for R2. So the formula for R2, as I told yesterday, was R2 is equal to 1 minus your summation of y minus yp. Okay, y minus yp का square divided by summation of y minus y bar का square. That is your formula for R2. Here we don't have any knowledge of how many features are there. N stands for number of feature. I don't have anything. Okay, so this is your error. This is your variance. Okay, so this is sum of the errors square. Okay, square sum. 1 minus square sum. And this is your variance. Okay, so that's your y minus y bar is the variance, and that is the square of the variance. So square of the variance, that's what you are having. This is R2. So identifying R2, finding R2 is not enough. To overcome this challenge, now we are having adjusted R2. This issue, we are having adjusted R2, which helps in telling that how many features are there. That's what adjusted R2 is. So if you are having overfitting also, we are going to tackle that. Okay, tackling overfitting also in adjusted R2. Because if you keep on increasing the number of features, if you think that okay, R2 is coming less, kindly increase the feature. So that's not happens in adjusted R2. No. It will like regularization. That means it will penalize. We are not going to increase the features if your model is getting overfitted. So if you are having a data having so many features and you have trained your linear regression model over that particular data, and then you have find out R2 score, it's good that you should calculate adjusted R2 also. Okay, adjusted R2 will give you a better response for that. Fine. So here is a formula for adjusted R2. 1 minus R2 square means R2 score divided by n minus 1. N minus 1 is your number of data point samples. NP is the number of features. Either you can take the notation. I have told the notation. N is the number of features. So it's you can take either of the notation. You can change it to P. It depends. So you can take N as number of samples. Okay, that means number of your rows. So rows is N and P is columns. You have to put into the formula. So adjusted R2 is better than R2. At least now I am having the knowledge. I am giving the information about how many samples and how many features are present. Okay, so it helps in preventing the overfitting by penalizing the addition of unnecessary feature. If there are unnecessary features, then it will penalize. R2 doesn't do that, but adjusted R2 do. So when to use adjusted R2? If you are having so many features in the data, you trained your model with those features. Okay, you got some R2 score, you got high R2 score. Okay, you at least try adjusted also. Maybe your model is overfitted. With R2, you are getting high score as 1. Maybe your model is overfitted. Who knows? Because R2 haven't keep into account of how many features are there, how many data points are there. No. But in adjusted R2, we put them. Okay, fine. So this is what adjusted R2 is. Yesterday I explained, and here also I did have a recall of the concept which I explained because there are very important points. Okay, so if you are using simple linear regression, simple LR, so R2 is just like Pearson correlation. Okay, Pearson correlation. R2 is equal to Pearson correlation. If you are using simple linear regression where you are having one feature and one target, तो वहां पर ये Pearson correlation is followed. Pearson correlation is summation of x minus x bar, y minus y bar divided by summation of x minus x bar ka whole square and summation of y minus y bar ka whole. So this is the formula for your Pearson correlation. Okay, so it's like this variance of x. No, it's xy. No, it's xy. Variance of xy, something like that. Okay, and then divided by sigma x and sigma y, something you can verify the formula, but this is the formula. Okay, fine. So here, in case of simple linear regression, the R2 is just a Pearson correlation. All right, got it. Now let's discuss ahead about okay, about what are the, if you are going to use linear regression model, linear regression. So what hyperparameters you can give into it? Hyperparameters you can give into it. Okay, fine. Now I'm sharing my entire screen for you. Okay, and kindly focus here for the hyperparameters. So you are going to use linear regression model. In machine learning, there is sklearn, which is the base library. This is the foundation. Okay, it's a base library, it's a foundation. All the libraries, linear regression, logistic regression, whatever been used in machine learning, na, are present in this library only. Okay, fine. Everything is present inside it. Okay. So from sklearn only we are going to import linear regression. So sklearn is a big package, and in sklearn we are having a package that is called as linear model, and in linear model we are having linear regression. This file, linear regression file. So if you need to perform linear regression, you have to import linear regression, this particular library, from sklearn. That's what you have to do. Okay. So it's written something like this: from sklearn dot linear model import linear regression. Linear regression. It's written like this. Okay, so this is actually a class, linear regression class. Okay, and if you want to use the functionality of this class, you have to create object. In OOPS concept, object oriented programming. Na classes and objects, classes and objects. Okay, so linear regression will be a class, and you have to create. Let us suppose I made model equal to linear regression. This is constructor to a class. You very well know. Constructor is having a same name as that of the class. In OOPS concept, we have studied everything. So linear regression is a constructor to this class, and obviously this will be an object of the class. Object of the class. And we can use this object. I just name it as a model. You can use this object to fit the data inside it. What is fitting, I will let you know ahead. Okay, I will know you. But just focus on this particular line. This line. What I have written? I have imported linear regression, and then I am creating the object of this particular class. So obviously this is a method. It's a constructor. We can load constructor. We can load it. So model equal to linear regression. You can give some parameters inside it. You know about the function overloading. So constructor is also a function. It's a member of a class with a class name. And whenever the constructor is invoked, the object is created of that particular class. That's a basic definition of object oriented programming. That's what we studied. Okay, you can load it. That will define your working of the model. How the model will work. That means that parameter will define, and there are certain parameters. Some models have so many parameters, some have certain parameters. Okay, so you can see them from the official website. This is the official website of sklearn. You can search the official website sklearn. Okay, sklearn.org. Okay, and from there you can find linear regression. Okay, so this linear regression, this linear model is having the parameters like fit underscore intercept, copy x, n jobs, positive. These are some parameters which are available in linear regression. Okay, so linear regression fits a linear model. Okay, it fits the linear model. What is a linear model? You very well know about the linear model. है ना? That is your y equal to beta naught plus beta 1x. That is a linear model. So that means it fit. If I have written na model dot fit x comma y, that means it is fitting the data x and y in this equation. That's what linear regression is doing. It is fitting this x and y into this equation. Okay, what else has been said here? To minimize the residual sum, that's what we do ना, minimum. है ना, ये तो हम करते हैं. That's what we do. That is summation of yp minus y का whole square by n. This is your cost function or error. We did perform a partial differentiation of this with respect to beta naught and beta 1. That's what we have already done. Okay, so it minimizes this function. That's what they are saying. We've already done the maths for it. Okay, so what are the parameters used in this particular function? The parameters are fit intercept. Okay, this is the parameter. Okay, that is fit intercept. So whether to calculate the intercept for this model or not, if it is set false, intercept will no intercept will be used in calculation. If it is true, by default it is true. That means intercept is calculated. That means the value of beta naught is calculated. If you by default it is true, this parameter is true. But if you're not, if you don't want the intercept to be there, then you can fix it as false. That's what you can mention, false. Okay, that is data is expected to be centered. Like, okay, when the intercept is not there, if you are having a line, it cuts like this. So ये intercept हो गया. And if you are not looking for the intercept, then I hope this is the line. This is how the line goes. So I don't have any intercept. It is crossing from the origin with no intercept. Okay, we are not calculating it. So this is how the line is going. Okay, that's what we say now, y equal to mx. Okay, so whether to calculate intercept or not to calculate intercept, that's mentioned. Copy x, that means if true, x will be copied, else it may be overwritten. X, that means your features, no? Training features. So either you can copy it, either don't copy it. If you say copy, then it will be copied, else it will be overwritten. So we are already having x. Okay, in your linear regression model, it is already having its an x, its own x, उसका है खुद का. आप जो अपना दोगे ना मॉडल डॉट फिट करने के लिए, आप दोगे ना एक्स कॉमा वाई, पहले तो मॉडल ऑलरेडी है और आप दोगे, तो या तो आपको कॉपी करना है इस चीज को, तो उसमें कॉपी कर दो. नहीं तो इफ यू आर नॉट डूइंग द कॉपी, तो वो उसको ओवर कर देगा. जो ऑलरेडी है उसकी जगह ये डाल देगा, बस ओवर राइटिंग. ओके, इट विल परफॉर्म ओवर राइटिंग ऑफ इट. तो हम तो नॉर्मली ओवर राइटिंग करते हैं, कॉपी नहीं करते. वी डोंट डू दैट, वी जस्ट ओवर राइट इट. कॉपी, ये मैंने कोई भी पैरामीटर यूज करे ही नहीं, ऐसे जरूरत नहीं. बट आपको मैं नॉलेज दे रहा हूं यहाँ पे. ओके, द फिर नेक्स्ट वन इज एन जॉब्स. एन जॉब्स का मतलब ये रहता है ना, फॉर द कंप्यूटेशन. ओके, इफ यू आर हैविंग a huge amount of data. Okay, if your problem is sufficiently large. Okay, so you can use all the processors for computation which are available in your CPU. So n jobs, this parameter you will see in many of the models hyperparameter. ये आपको हर जगह मिलेगा, लगभग हर एक मॉडल के अंदर दिस हाइपर पैरामीटर विल बी देयर. एन जॉब्स का मतलब ये रहता है कि आप पैरेलल प्रोसेसिंग कर लो बस. ओके, पैरेलल प्रोसेसिंग. That means if you are having a huge data to process, तो आप ऐसा कर दोगे n jobs equal to -1. तो जितने भी कोर्स हैं सीपीयू के अंदर, हाउ मेनी कोर्स आर, वट एवर बी द कोर्स विच आर अवेलेबल इन द सीपीयू फॉर द कंप्यूटेशन, सबको उठा लेगा. फॉर एग्जाम्पल, यदि आपके पास 8 कोर है, इन योर सीपीयू आर हैविंग 8 कोर्स, 8 प्रोसेसिंग यूनिट्स हैं, तो इट विल पिक अप ऑल 8, सबको बोल लेगा और बोलेगा कि आप मेरे डेटा को सॉल्व करिए. Okay, so in that particular situation, you can use n jobs. You can put n jobs equal to -1. It will use all the cores which are present in your CPU for processing. ठीक है, ये अच्छी बात है. स्पीड अप हो जाएगा. दैट्स व्हाट इट इज सेइंग ना. स्पीड अप करने के लिए पैरेलल प्रोसेसिंग कर लेगा बैकएंड पे और स्पीड अप कर देगा वो. ओके, तो -1 कर दीजिए, ये बोल रहा है यहाँ पर -1. ऑल प्रोसेसर्स का यूज करेगा. ओके, नन का मतलब 1 है, यानी ओनली 1 प्रोसेसर इट इज यूजिंग, नॉट ऑल. तो कोई बात ही नहीं, बाय डिफॉल्ट नन ही होता है वो. फिर होता है पॉजिटिव. दैट मीन्स व्हेन सेट टू ट्रू फोर्सेस द कोएफिशिएंट टू बी पॉजिटिव. Okay, so value of beta naught, beta 1 and all these things, no, they will be forced to get the value as positive. ओके, बाय डिफॉल्ट फॉल्स होता है, हम उसको वो नहीं कर रहे, ठीक है, प्रेशर नहीं कर रहे कि तू पॉजिटिव कोएफिशिएंट निकाल सर। ओके फाइन, यस सर। ओके, तो ये आपके जो है पैरामीटर्स हैं, दीज पैरामीटर्स यू कैन यूज। ओके, इन लीनियर रिग्रेशन ये 4 पैरामीटर्स हैं आपके पास, ज्यादा नहीं है लीनियर रिग्रेशन, दे आर सर्टेन, आई ऑलरेडी टोल्ड ना, कम है यहाँ पे पैरामीटर्स। ओके, देन देयर आर सर्टेन एट्रीब्यूट्स आल्सो, जैसे कि कोएफिशिएंट। ओके, इट्स एन अरे ऑफ shape and features or and targets like that. Okay, so we can print the coefficients of model। हम ऐसा लिख सकते हैं मॉडल डॉट सी ओ ई एफ अंडर स्कोर, दैट्स वॉट। आपका मॉडल ट्रेन हो गया। ओके, वंस योर मॉडल गॉट ट्रेन्ड, लेट मी राइट इट, और मेरी एक एक लाइन, एक एक वर्ड, एवरी वर्ड यू हैव टू लिसन वेरी केयरफुली। आप once your model is trained, once your model is trained, then you can use attributes। और आपने वो पैरामीटर्स को कहाँ यूज करा था, वेयर यू हैव यूज द पैरामीटर्स, यू हैव यूज द पैरामीटर्स इन ट्रेनिंग द मॉडल। अंतर समझना, व्हेन यू आर राइटिंग मॉडल इक्वल टू लीनियर रिग्रेशन, यहां पर आपने पैरामीटर्स को पुट करा था। once the model is trained, then you can use the attributes, like you can write model dot coef underscore, तो ये कोएफिशिएंट्स की वैल्यू दे देगा। इट विल गिव यू एन अरे ऑफ द, अच्छा अरे देगा, ये अरे ऐसा देगा, ये ऐसा। और कोएफिशिएंट क्या है भैया, क्या है कोएफिशिएंट, कोएफिशिएंट है बीटा नॉट, बीटा 1, बीटा 2, बीटा 3, ये कोएफिशिएंट्स हैं। इट विल प्रिंट दीज वैल्यूज इन अ फॉर्म ऑफ एन अरे। और करना चाहिए आपको, यू शुड प्रिंट द वैल्यू ऑफ कोएफिशिएंट। भाई मेरे को बता तो दे कि तूने क्या क्या वैल्यू कैलकुलेट करके रखी है कोएफिशिएंट्स की, क्योंकि ट्रेनिंग का मतलब तो द मीनिंग ऑफ द ट्रेनिंग इज दिस ओनली, टू आइडेंटिफाई द कोएफिशिएंट्स टू फाइंड द ऑप्टिमल वैल्यू ऑफ द कोएफिशिएंट। सो काइंडली लेट इट नो, काइंडली टेल अस व्हाट आर द कोएफिशिएंट वैल्यूज। तो बता देगा ये, मॉडल डॉट सी ओ ई एफ अंडरस्कोर करोगे ना तो प्रिंट करेगा ये कि मैंने क्या वैल्यू निकाली है कोएफिशिएंट की। ठीक है, you can print a rank, that means rank of a matrix of x only available when x is dense। dense होगा तो ही पता चलेगा, नहीं तो कोई मतलब नहीं है। dense, ये dense फेंस क्या होता है, ऊपर भी बोल रहा था dense। ओके, dense, एक होती है dense और एक होती है sparse, में जीरो ज्यादा होते हैं, dense में नहीं होंगे। ओके, so it will print the rank of your matrix, आपका डेटा, उसकी रैंक प्रिंट करेगा। Singular, that means array of shape min of x comma y, that means singular value of x only available when x is tens। ओके, ये प्रिंट करके देखेंगे क्या रैंक है, क्या है, जब मॉडल करेंगे। इंटरसेप्ट की वैल्यू प्रिंट करवाना तो इट विल प्रिंट इंटरसेप्ट आल्सो। व्हाट इज द वैल्यू ऑफ इंटरसेप्ट। ओके, ये भी वो प्रिंट, इंटरसेप्ट क्या था, बीटा नॉट था ना, इट विल प्रिंट। देन नंबर ऑफ फीचर्स सीन ड्यूरिंग द फिट, हाउ मेनी फीचर्स, ये तो हमने खुद ही ने डाले थे ना, उसके अंदर आपको पता ही होगा हाउ मेनी फीचर्स आर, ये भी प्रिंट वो करवा देगा इफ यू वांट, इट विल डू। ये आप मॉडल ट्रेनिंग के बाद दीज एट्रीब्यूट्स यू कैन प्रिंट करके देख लेंगे अभी। ओके, दैट्स व्हाट वी कैन डू। लीनियर रिग्रेशन के वर्जन 0.24 के अंदर ये एडिशनल एट्रीब्यूट शायद ये भी आ गया, फीचर नेम्स इन, वो फीचर्स का नाम भी प्रिंट कर देगा, कौन कौन से फिट हुए। ठीक है, व्हाट फीचर्स आर यूज्ड फॉर द मॉडल ट्रेनिंग, तो उसका नाम। तो अभी तक तो फीचर हाउ मेनी फीचर्स आर देयर नंबर्स थे, बाद में ये आगे वाले वर्जन में भी ये सब ऐड हो गए, ये वर्जन 1.0 वगैरह, तो ये सब वर्जन्स हैं आपके लीनियर, दे आर अपग्रेडेड, these all things can be printed। okay fine, so these are the parameters and these are the attributes of your linear regression model, and you have one like a code, simple code, which we can run on our machine। okay, so let me take this code, Okay, and we can run on the machine for your demonstration purpose. So import numpy as np. That's a numerical Python to do linear algebraic operations. Then we are taking sklearn.linear model import linear regression. I already given you statement. This is statement. So linear regression is imported from linear model of sklearn. From here only it is imported. And then we are making input x and we are making output y. You can take any data, but okay, here it's just taken as a example. Okay, so this is your x and this is your y. Okay, and equation of y is like this: 1 into x naught plus 2 into x1 plus 3, like this. Then I fitted data into linear regression model. I want to print the score, I want to print the coefficient, I need to print the intercept, I need to predict the value also. What will be the result? I want to do all these things. Let me run the code. Okay. So I think it's better that you should print one by one, not in a hurry. Okay. And one more thing, I guess the good approach is you should do like this: reg dot fit x comma y. This is how you should do. Okay, fine. So this is your x, this is your y. You have defined from your side, and if you want to print x and y, let me print them also for you. ओके, तो ये देखिए आपका ये 2D अरे है. दिस इज योर 2D अरे एंड दिस इज योर वाई. 2D अरे है, वो क्यों 2D अरे है? बिकॉज ये x1 फीचर की वैल्यू है. दीज आर x1, these are x2. Okay, that's the reason it took x0 and x1, two features it considered. Okay, x0 and x1, two features it considered. All right, so that's why it made a 2D array. Okay, and then according to this equation it calculated y. Okay, ये y है आपका. ओके, तो y के लिए उसने ये इक्वेशन बना ली, 1 इंटू एक्स जीरो प्लस 2 इंटू एक्स वन प्लस 3, ये इक्वेशन है. तो उसने कैलकुलेट कर लिया, द वैल्यू ऑफ y 6 8 9 एंड 11. फाइन. तो आपका डेटा कैसा बन गया? हाउ योर डेटा लुक्स लाइक? योर डेटा looks like this. Okay, it looks like this. You are having x0 and x1, x0 and x1, and this is your y. So you are putting the values according to 1 1 1 2 2 2 2 3 1 1 1 2. Okay, so 1 1 1 2 2 2 3 3. Okay, and what is the value of y you are getting? 6 8 9 11. Okay, 6 8 9 11. All right, now you are putting this as x in linear regression and this as y in linear regression model. Okay, so what you did, model dot fit x comma y. Okay, you can use model or r, you can use reg, whatever name you want to use, you can do. So ये आपकी जो क्लास थी लीनियर रिग्रेशन की, आपने इसका ऑब्जेक्ट बना लिया एंड देन यू आर फिटिंग इट टू द, you're fitting the x and y in linear model, in linear equation. फिट करने के बाद ये मॉडल ट्रेन हो गया. एज यू सी दिस, your model got trained. Now you can print the scores. Okay, one by one you can print the score. Control C. Let me print the score. 1. The score is 1. Okay. What score it is? R2. Coefficients 1 and 2. The coefficients are 1 and 2. So this is your beat. What it is, 1 and 2, what the coefficient is. Where are the coefficients? You can see these are the 1 and 2, these are the coefficients. Okay, and then next is your intercept. Okay, intercept. Let me print the intercept. What is the intercept here? Okay, value of intercept. It is 3. You know it. This is 3. Intercept. So coefficients and intercept. And then what is, if I need to predict something? If the x1 is 3, y1 x1 is 3, x2 is 5, what is the output? 16. This is your model predicted. The value of y is 16. That's what the prediction is. And if you want to have few more things like rank, if you want to print the rank, so you can do that also. Reg dot rank. That's also you can do. Okay, do I have underscore? Yes, underscore. So to tell you the rank 2. दिस इज द रैंक ऑफ द मैट्रिक्स. ये इस मैट्रिक्स की रैंक है. ये जो मैट्रिक्स है ना, ये इसकी रैंक है. ये आपकी बन रही ना मैट्रिक्स 1 1. इसको मैं बना रहा हूँ ऑगमेंटेड 6 1 2 8 2 2 9 2 2 9 एंड 3 3 11 3 3 11. ये मैट्रिक्स की रैंक है वो. दैट इज 2. रैंक वी हैव ऑलरेडी स्टडीड. ओके फाइन. एंड देन what else you want to print? Singular. तो सिंगुलर प्रिंट करना है, इंटरसेक्ट कर देना. एन फीचर्स इन, if you want that. N features in. So yes, you can. Here are reg dot n features in. Okay, n. Fine. That's what you can print here. Okay. 2. There are two features x1 and x2. सही print करा. उनके नाम बताना है आपको. Okay, if you want to print the names of those features. Okay, let's see. Reg dot print the names of the features. Now it's showing error. This is present in upgraded version. Actually, my version of the sklearn is not upgraded. That's why it is throwing an error. It told na कि the names of the features seen during fit defined only next features only in the string added in version 1.0. My version is not 1.0. My version will be lower than 1.0 till 0.24 ऐसा कुछ है. तो उसने यहाँ तक जो भी एडेड था इट टोल्ड. बट इफ आई वांट टू प्रिंट दिस थिंग आल्सो, मुझे अपग्रेड करना पड़ेगा. तभी उसने रिस्पॉन्स नहीं दिया. तो आई एम नॉट प्रिंटिंग इट, कोई इशू नहीं. This is how you can use a linear regression, and you can try it from this. Okay, from this official website, a simple code. Okay, ये आप कर सकते हैं. Got it. ठीक है. तो भाई ये अभी लीनियर रिग्रेशन के बारे में, दैट्स व्हाट वी हैव स्टडीड. ओके फाइन. तो भाई मैं आपको एक बार और रिकॉल करना चाहूंगा. जस्ट गिव मी सम मोर टाइम. आई वांट टू हैव अ रिकॉल. ओके, रिकॉल में ये है कि लीनियर रिग्रेशन सुपरवाइज्ड मशीन लर्निंग एल्गोरिदम, इट इज regression analysis. Regression means your target is continuous in nature. It is continuous in nature. That's a target. Okay. And you can have simple linear regression. You can have multiple linear regression. Both you can have. In simple linear regression, you are having x and y. In multiple, you are having x1, x2, x3, x4, and so on, and y. That is multiple linear regression. Okay, this kind of relationship, actually we are looking forward to have a relationship, and the relationship is defined as linear. That means that's what we are expecting, that the relationship between x and y is linear. So we call independent and dependent, and that's how the relationship is identified for linear regression. There are certain assumptions to use for linear regression. I also told about them, what the assumptions are. That means you should have like one is the assumption linear relationship. Then you should have normal distribution. Okay. Then no correlation, no collinearity. Your residuals should also be normally distributed. They should have equal variance. These are certain assumptions which you have to follow before applying the linear regression. Okay. Then how to apply linear regression? That's what you have seen today in the implementation. How to do it. Okay. By checking this code, how to do it, and you can use these parameters, these hyperparameters. You can put these hyperparameters into the linear regression model. Okay. And see how the results are varying. You can evaluate your model. Okay, you can evaluate your model, linear regression model, by the terms like MSC, MAE, RMSC, R2, adjusted R2. We used MSC for our as a cost function to calculate the values of beta naught and beta 1. A very important step, very important derivation. Okay, this is used, it's a major thing for evaluation. If its value is very much high, then you can go on MAE or RMSC. If its value is very high, then try with RMSC. Find the root of MSC, that will be RMSC. Else you can go ahead with MAE also, because MAE will be small, because showing a huge error is not significant. So MAE will be small. So try, if this is huge, try both, see which is less. So ये तो error वाली बात हो गई. Next comes the variance explained, which I again taught today. Variance explained. In variance explained, you are keeping R2 and adjusted R2. R2 is just telling that how much features are contributing to get the value of Y. How much percentage they are contributing to get the value of Y. That is called as variance explained. Formula you very well know. If you keep on adding the features, more feature, and the value of R2 is increasing, okay, fine, but it may lead to overfitting. So to avoid overfitting, we use adjusted R2, which will let you know that how many features are added, how many samples are there, because in that formula we are having N and P. How many sample, how many features are there, M and P. So if you are having overfitting issue, kindly use adjusted R2. That's it. All right. So how you find today's class? That means you guys are there. You understood the concept? Okay. Yes, Ayush.
Yes, sir, I understand. Sorry, by mistake.
Okay, understood. Fine. So in the next class, I'm going to talk about polynomial regression. Okay, I'll talk about polynomial when the relationship between x and y is not linear, polynomial. Then what to do? ओके, होता है ऐसा इशू आ जाता है जब लीनियर फिट नहीं होता, तो पॉलिनॉमियल के लिए वी विल अप्रोच. ओके, फाइन. यस राम सर.
Sir, please send the notes, sir.
सर नोट्स आई शेयर ना इन द ग्रुप सर, दे आर इन अ ड्राइव.
Okay, in this mail or like.
Sir, I will check sir, are you in a group or not? I shared sir.
Okay, sir.
Okay, fine. All right, let me stop presenting. Okay.